Welcome, curious minds, to a journey that delves into the enchanting world of rainbows. Have you ever wondered how those vibrant bands of color appear in the sky after a rain shower? And why do they create that mesmerizing arc shape we all know so well? Join us as we peel back the layers of nature's canvas and reveal the captivating science behind the formation of rainbows. Today, we embark on an exploration into the mysteries of sunlight, water droplets, and the captivating phenomenon that results in a breathtaking display of colors overhead. So, are you ready to dive into the realm of rainbows and uncover their secrets? Keep watching, because by the end of this video, you'll have the answers you've been seeking. A rainbow is a meteorological phenomenon that occurs when sunlight is refracted, or bent, as it passes through water droplets in the atmosphere. This bending of light causes the different colors in the spectrum to spread out and form a circular arc of colors in the sky. The primary colors of a rainbow are red, orange, yellow, green, blue, indigo, and violet, with red being on the outer edge and violet on the inner edge. Rainbows usually appear when there's a combination of sunlight and rain or other water droplets in the air. The sunlight is both refracted and internally reflected within the water droplets, creating the separation of colors. The phenomenon is particularly visible when you're standing with your back to the sun and looking toward the area where rain or droplets are present. A double rainbow can sometimes be seen, where a fainter and larger outer arc forms alongside the main rainbow. This occurs due to the light undergoing a second internal reflection within the water droplets. The formation of a rainbow begins with sunlight, which is a mixture of different colors, wavelengths, of light. Rainbows occur when this sunlight encounters raindrops or water droplets in the atmosphere. When sunlight enters a water droplet, it slows down and changes direction due to a change in speed caused by the change in the medium, from air to water. This phenomenon is called refraction. The different colors in sunlight have slightly different wavelengths, so they refract at slightly different angles as they enter the droplet. Once inside the droplet, the light is reflected off the inner surface of the droplet. This reflection is similar to how light reflects off a mirror. The internal reflection occurs at the back of the droplet, away from where the light entered. After the internal reflection, the light exits the droplet. Again, it undergoes refraction as it moves from the water back into the air. The different colors continue to refract at different angles due to their varying wavelengths. The combination of refraction and reflection causes the different colors to spread out within the droplet. This phenomenon is known as dispersion. As they spread out, the colors are now more separated than they were in the original beam of sunlight. Finally, the dispersed colors exit the droplet, spreading out in all directions. This forms a circular arc of colors in the sky. The different colors exit the droplet at different angles, with red being bent the least and violet being bent the most. To see a rainbow, you need to be positioned with your back to the sun and looking toward the area where raindrops or water droplets are present. The sunlight entering the droplets, undergoing internal reflection, and exiting the droplets forms the colorful arc that you see. Why does the color of the rainbow arrange that way? The arrangement of colors in a rainbow, known as the color spectrum, is a result of a phenomenon called dispersion. Dispersion occurs due to the varying wavelengths of light, which determine the colors we perceive. Here's why the colors of a rainbow are arranged in a specific order. Light consists of a spectrum of different wavelengths, each corresponding to a different color. Shorter wavelengths are associated with violet and blue colors, while longer wavelengths are associated with red and orange colors. The colors are arranged in a consistent sequence from the outer edge to the inner edge of the rainbow: red, orange, yellow, green, blue, indigo, and violet. This order is a direct result of the varying angles of refraction and reflection that each color experiences within the water droplets. The colors of a rainbow overlap and blend into each other. The distinct bands of color that we perceive are a result of our eyes seeing the range of colors that were dispersed and refracted within each droplet. The original shape of a rainbow, as it forms in the sky, is actually a complete circle. However, the ground obstructs our view of the lower half of the circle, making it appear as an arc when observed from the ground. In situations where sunlight and raindrops are present, such as during or after a rain shower, the sunlight is refracted, reflected, and dispersed within the water droplets in the atmosphere. This creates a circular pattern of colors in the sky. The circular rainbow pattern is centered on a point directly opposite the sun in the sky. The visible portion of the circular rainbow that we typically observe is the upper half of the circle, forming an arc that appears to touch the ground. The ground and horizon obstruct our view of the lower half of the circle. This is why we commonly see rainbows as an arc rather than a complete circle. However, under special conditions such as when you are viewing a rainbow from an elevated location, such as a hill or an airplane, you might be able to see more of the circular rainbow, including the part that would normally be hidden below the horizon. In such cases, you could witness a more complete circle of colors in the sky. And there you have it, an insight-packed journey into the science of rainbows. From the intricate interplay of light to the captivating process that brings forth a spectrum of colors in the sky, we've explored the very essence of this beautiful natural phenomenon. Now, we want to hear from you. Have you ever witnessed a rainbow in all its vibrant glory? What was your experience like? Share your thoughts and stories in the comments section below. Don't forget to hit that like button if you found this exploration fascinating, and remember to subscribe to our channel for more exciting insights into the wonders of the world around us. Until next time, keep your eyes to the sky and your curiosity ignited.